In this video, we will introduce to the operations on vectors. Let us assume two vectors x and y having 5 elements. Like mathematics, in R also we can add a scalar to a vector. For example, x plus 1 when we add, here x is a vector, 1 is a scalar, then 1 will be added to each element of x. Like mathematics, in R also we can add two vectors. Here x and y are two vectors having 5 elements. So when we say x plus y, each element of x is added to the respective element of y. The result is having 5 elements, that is same size of the either x or y. We can have expressions involving vectors and scalars also. For example, x plus y plus 1 is a valid statement here. In this expression, first element of x plus first element of y plus 1 will become the first element of the result. Similarly, second element of x, second element of y, and 1 sum becomes the second element of the result. Like this expression will be evaluated. While adding scalars to vectors, associative rule is valid. Thus, 2 plus x value is same as x plus 2, where x is a vector. Now let us try to change the size of the vector y. Let us try to add x and y. You remember, their sizes are not same. X is having 5 elements and y is having 7 elements. Of course, in mathematics, this is not acceptable. However, we wanted to know in R what will be the results. Certainly, on the screen we will see the results, and also we have an error message, warning message. Longer object length is not multiple of shorter object, etc. However, we have seen the results. In R, two vectors of different size can be added or subtracted or multiplied also. However, the larger one size should be exact multiple of smaller one size. If not, we get a warning message as shown in the screen. Now we try to add x and y. Before that, we will add some more elements to y such that its size becomes exact multiple of size of x. When we try to add x and y, we did not get any warning message this time. While doing operations on vectors, if both the sizes are not same, then the elements of the smaller array will be recycled. For example, in this example x plus y, x contains 5 elements, whereas y contains 10 elements. Thus, first 5 elements of x are added to the first 5 elements of y. At the same time, last 5 elements of y also gets added with 5 elements of x. This is known as recycling. You can see our explanation in the slide. This recycling takes place even if the vector sizes are not exact multiples. Only difference is we get a warning message. We can carry all the operations on vectors. We can add 2 vectors, we can subtract 2 vectors, we can divide 2 vectors, we can multiply 2 vectors. All of them are carried out in element by element fashion. Verify the results on the screen. R supports power operator also. When we say x cap 2, each element of x will be raised to 2. Thus, we get results 1, 4, 9, 16, 25. When we execute this expression x cap 2 cap 2, each element of x will be raised to 4 because 2 cap 2 that is 4. So each element of x will be raised to 4. Thus we get 1, 16, 81, 256 and 625 as the results. X cap y. First element of x is raised to 6 times. Second element of x will be raised to 7 times. Third element will be raised to 8 times. Fourth element will be raised to 9 times. Fifth element will be raised to 10 times. That is, x of 1, first element of x is raised by y of 1 times. Similarly, x of 2 will be raised to y of 2 times. This is how this operator works. Sometimes we get results of an operator will be infinity also, as shown in this example. We have another operator which also does the same as cap operator, powering operator, that is into. x into 2 is nothing but squaring each element of x. This is same as x cap 2. The other things also equally meaningful. We can use relational operators between vectors or with vectors. Maybe between a vector and a scalar. If it is between a vector and a scalar, then each element of the vector and scalar, between that the operator will be worked out. Otherwise, respective elements will be taken and the relational operation is applied. The result of a relational operator is true or false. Thus, if x is a vector, x greater than 1 becomes a vector of same size as that of x with true or false. That is a logical vector. Like this, we can have logical vectors as the results. We have logical operators like greater than, less than, greater than or equal to, less than or equal to, not equal to, etc. which can be applied between a scalar and a vector or between two vectors, etc. We have functions such as log, log10, etc. If we apply these functions on scalars, we get their respective logarithm values. If we apply these functions on a vector, then these functions are applied to each element of those vectors. Of course, the result is a vector. This is how these functions will work or behave when we use with vectors. We can also use exp function, sin function also on vectors. When we apply these functions exp, sin, etc. on a vector, they are implicitly applied on each element of the vector. Square root function, when applied to a vector, for each element of that vector, square root is calculated. The result is a vector. However, we can also use functions such as max, min, sum, mean, etc. When we send a vector as argument, we get a scalar. Max of x returns maximum value of x. Min of x returns minimum value of x. Sum of x returns total value of x. Mean of x returns average of x. Like this, these functions max, min, sum, mean, they return a scalar. Range function, when applied to a vector x, we get the lowest and highest values of x as the results. When we apply product function to x, we get sum of the elements product of x. Sort of x returns sorted array, sorted vector of x. Length of x returns number of elements in x. In this slide, we have explained how Pmax, Pmin works. The functions Pmax and Pmin takes two arguments. The arguments can be two scalars, or a scalar and a vector, or vectors also. If both the arguments are scalars, their minima or maximum will be returned. If one is scalar, another one is a vector, then each element of the vector and the scalar is compared to find out either maxima or minima. If both the elements are or both the arguments are vectors, then each element are compared, either minima or maxima is calculated. Depends. If you use P maxima and both the arguments are arrays, then the minimum of the respective elements will be taken. If we use P max with the two vectors, then maximum of the respective elements will be taken. Like this, these functions P max and P min works. In this video, we have explained how various operators, arithmetic operators and relational operators works with vectors. Also, we have explained how we can call various functions like mean, max, min, range, pmax, pmin with vectors. If you like this video, please do advise your friends to subscribe my channel. Thank you.